Okay, so picture this. A famous star, one you can actually see in the constellation Orion, suddenly starts to, well, fade. It gets so dim you can see the change with your own eyes. That is exactly what happened with Betelgeuse. And for a minute there, it really looked like we were about to see the greatest show in the night sky, a full-blown supernova.
And that was the big question, right? The one on everybody's mind back in late 2019. Astronomers, stargazers, everyone was looking up and noticing something was seriously weird. It kicked off this huge debate. Were we watching the final moments of one of our galaxy's most famous stars?
So, to really get a handle on this, you gotta understand just how mind-bogglingly huge Betelgeuse is. This isn't just any star, it's a red supergiant. To put that into perspective, if you could just swap our sun out for Betelgeuse, it would swallow Mercury, Venus, Earth, Mars, and its outer edges would stretch all the way out past Jupiter. It is an absolute monster. So, here's the play-by-play. It all started in October 2019. The star just starts to fade. By the middle of February 2020, it had lost a massive amount of its brightness. We're talking more than 2/3 gone. So much that you could literally see the difference from your backyard. It was completely unprecedented. And then, just as weirdly as it all started, by April, it was back to its old, bright self. What on earth was going on? All right, so to figure this mystery out, scientists pointed one of our best eyes in the sky at it, the Hubble Space Telescope. And what it found wasn't a star about to blow itself to bits, but something that was actually more like a giant cosmic smoke signal. And what they found is, well, it's pretty wild. Betelgeuse basically had a giant cosmic burp. A huge chunk of super hot plasma got shot out from its surface. As this blob of material flew outwards into space, it started to cool down. And as it cooled, it condensed into a massive cloud of, well, dust. This dust cloud was so big it created a kind of smoke screen, blocking a huge part of the star from our view here on Earth. So the big takeaway here is that this great dimming wasn't the star's death rattle at all. It was all happening on the surface, kind of like a crazy stellar weather event. The star's core was fine. It was just playing peekaboo behind a giant cloud of its own making. Which, leads us to the real question, doesn't it? If something that dramatic isn't the final warning sign, then what is? How are we ever going to know when a star like Betelgeuse is truly about to go supernova? And the answer is just so cool. The real warning sign isn't something we're going to see with our eyes. It's going to come from something we detect, these invisible little messengers that are born deep inside the star's collapsing core. I mean, think about it. We just saw how easily light can be fooled, right? A star can be doing its thing, and a simple cloud of dust can trick all of us into thinking the end is near. When it comes to a supernova, light can be a pretty unreliable narrator. But what if there was a messenger that couldn't be blocked, that didn't care about dust clouds or even the outer layers of the star itself? Well, that's where neutrinos come in. These things are the ultimate cosmic messengers. So what are these things? Neutrinos are these tiny, tiny ghost particles that are created during the crazy nuclear reactions happening in a star's core. As a star like Betelgeuse starts to die, its core collapses and it unleashes an unbelievable blast of these neutrinos. And because they barely interact with anything, they escape the star instantly and rocket towards us at almost the speed of light, carrying the very first news that the star is doomed. And here's the best part. We're not just crossing our fingers hoping to catch these things. There's an incredible alarm system already built deep underground in Japan, and it's listening right now for the final whispers of dying stars. This whole system is basically a 1-2 punch from two amazing detectors. First, you've got Cumland. It uses this special liquid that gives off a tiny flash of light when a neutrino zips through. Its superpower is being incredibly sensitive, so it can pick up the very first faint signals. And then you have its partner, Super Kamiokande, which is just this colossal tank of unbelievably pure water. Its size is its advantage. It's a huge target, perfect for catching the flood of neutrinos that follows, confirming the signal is real. They're the perfect team. Together, this system is so powerful it can detect the warning signs of a supernova from up to 510 parsecs away. Now, don't get hung up on the word parsec, it's just a way astronomers measure huge distances. The important thing is, that's about 1,660 light years. And Betelgeuse? It's sitting at a comfy 168 parsecs away. It is well within our detection range. And this is the real game changer. This is the whole point.
Once those detectors catch that burst of neutrinos, an alarm goes out to astronomers around the world. And depending on the exact physics of how the star dies, which we have different models for, we could get anywhere from a few hours to more than 12 hours of advance warning. That's a 12-hour head start before the light from the actual explosion even gets here.
But what about false alarms, right? I mean, you don't want to cry wolf. Well, get this. The system is so good. They expect maybe one false alarm per century. So when that alert goes out, you can be pretty darn sure that it's the real deal. Okay, so the alarm goes off. The neutrinos are here. Every telescope on and off the planet swings toward Betelgeuse. What happens then? What do we actually get to see?
But hang on, before we get to the fireworks, let's talk about the elephant in the room. A star exploding this close? I mean, that sounds dangerous. Are we in any trouble?
And the answer, thankfully, is a huge, resounding no. While Betelgeuse is one of the closest supernova candidates we have, close in cosmic terms is still hundreds of light years away. We are at the absolute perfect distance to have a front row seat for the show without being anywhere near the danger zone.
So what do we get to see? Only the greatest show in the night sky. I'm talking about a spectacle that no human in modern history has ever witnessed. When it blows, Betelgeuse will shine as brightly in our sky as the half moon. It'll be so bright you can see it in broad daylight. And this isn't just a flash in the pan. It's going to stay that bright for more than 3 months.
Look, we have no idea if this will happen tomorrow or 100,000 years from now. But what's incredible is that when it does, we'll be ready. We'll have hours of warning. We will get to look up together. Just try to imagine that. A huge part of the entire world, all staring up at the same point in the sky, just waiting for the light show to start. And the cheer that will go up around the planet when it finally does.